Hello, Internet. Yesterday we ran into a problem. So this is what we ended up with. This is our generated quad tree. It's supposed to only have quads being generated for where it is. So you can see that's not entirely the case. So like this one, that shouldn't exist right now. We're only supposed to be drawing these for the leaf nodes. Unfortunately, that code is broken. So we incorrectly defined our leaf nodes as things without children. What we meant to do is actually define them as things that are at the deepest depth of our tree. So things that are at the maximum depth. That's not what's happening now, so we need to fix that. And we had another issue. Right, sorry. So the other issue is our values are not being saved. So there's no actual information being inserted into this graph. We create the tree, and then we just kind of leave it there. There's nothing being stored. Which, honestly, that makes this more or less useless. So we're going to fix both of those in this video. It's not going to be... We're not bringing any new features in. What we're going to be focusing on is actually getting this stable and to a point where we can actually build our next steps on this. So this is where we're starting with. We need all of those to go away, which means we need to fix our leaf node detection, and we need to be able to insert values. So I imagine this is going to be fairly easy. There might be a little bit of poking around. So the first thing I'm going to do actually is return the Quadtree node. There we go. So we're going to return our Quadtree node from our subdivide, and this is going to be a recursive algorithm. It already is recursive because every subdivide calls subdivide. And so what we can do is we can have it return the depth if it's equal to that. Otherwise, we can return ourselves. Else return this. So if the depth is equal to 0, then we'll return this. And if it's negative, then we also return this because it should never get negative. And so this should, emphasis on the should, return the subdivided node. And I think that should be enough to actually allow us to set the value for this, because we already have the value here. And so I can just expose this. We're going to make this a protected set. So this is going to only make it so that things that are extensions of this class or that are this class can actually modify it, so that can set it, which I think, ooh, that's not going to work. That's not going to work at all. Can't call that value. What do we want to call it then? So we need to do some refactoring magic here, because we called it value, and in setters, value is a keyword. That is the current value being passed into the setter. So that will break everything. So we have to fix that. We have to change it so it doesn't use that. The best thing, value, synonyms for value. Value, data, sure, that'll work. So we'll change that, and I think it's asking us if we want to change our property as well. So again, this is ReSharper, so it's going to do a little bit more than the standard Visual Studio. It's extension by IntelliJ, so that's where all those menus are coming from. But as you can see, it renamed everything from value to data, which means we want this .data there, and we want to set it to the value, and that fixes that issue. So now we're getting a data point out. So we can actually save out the leaf node. So eventually this subdivision is going to return our leaf node because of how this is working. we go all the way down to a depth of 0, and then that is going to be our leaf. That's going to be whatever leaf node we're at. And then it's going to return it all the way up because this just keeps returning the selected one. So we attempt to find the index we want, and then we return that index. And so what this is going to do is it's just going to subdivide down and then return the result all the way back up. And so we can use that to actually set the data there. So we should be able to just do leaf node equals node dot something. Not that. We want to just set it to the value. So the leaf node dot data is equal to the value. And that's not going to work because it's protected. So I'm going to make this internal instead, which is sort of the next step up. So only things in the same library, in the same namespace can see it. Everything else can't. So if you give this library to somebody else, they have no idea. They have no way to set the data manually, which they may want to do, but we're not going to let them because it's kind of getting around some of the functions of our Quadtree. But it will allow our Quadtree to actually see it. So that's good. We should be setting our value now, which theoretically means that everything should actually work now because our default values will be null. So if I jump back here, go to our Quadtree and just click generate, still not working. I must have skipped. Oh, we had skipped that part. So there's the mesh creator here, and we had this if leaf or whatever. We needed to actually check the value. If leaf dot data, then we want to draw it. So this is not fully going to be done, but it may appear done. Just simply because everything that is in the leaf node is going to default to false. So it's actually working just by coincidence. Or it's not working at all. That's interesting. That wasn't what I expected at all. One sec. We have screwed something up. Not we. I have screwed something up. So how do we fix this? We need to set the data there. We set the value. That's kind of weird. I wonder why this isn't working. So we bubble down, and then we bubble back up. Okay, I think we're gonna have to come back to this. And the reason I'm saying that is not because we're not gonna fix it, but because it's gonna get easier to debug once we get this get leaf nodes functioning properly, because right now it's returning things that aren't the leaf, which means things will be true and false. If we can get this functioning properly, then we should, theoretically at least, be able to only see the leaves, which the advantage there is everything should have the same behavior at that point, because we're always setting true, unless yeah, we're inserting true. So that's not the problem, unless me not saving was. One sec, just gonna check if not saving was, because it always has that thing as a possibility. No, okay, that's not the issue. Good. I hate when that's the issue. So ignoring that now, we're going to move on to this isLeaf, which currently we're detecting if there's no subnodes, which is so in a normal tree that would be correct. It'd be a leaf node, which is just an outer node with no children. We're not defining it as that. We are going to say it's a leaf node if, sorry, I was confused if I was inside the inner class or not. Anyway, it's a leaf node if its depth is equal to 0. So if its depth is equal to 0, then it's a leaf node. And so what that means is it means we need to actually save our depth into each of our nodes. And there's two ways to do that. We could either save it here, or we can save it in the constructor. We're going to save it in the constructor because that's the best way to do it. I don't know, it may not be the best way to do it, but it's the best I can think of right now. I don't see why you wouldn't, because we want everything to have a depth value. That's just something that we need to know. So we're going to do depth equal, or depth minus 1. Yeah. Is that correct though? No, it's not. We want to just do depth. And so this is going to subdivide it and set the depth of each of those nodes. So then we need to fix this as well, our initial one. We're going to set that to our depth. And so this way, the depth used in this Quadtree node, that's actually going to be the depth that we're going to pass everywhere. So the advantage, now we just have a really, the check is pretty much the same for isLeaf. We're just doing it a little bit differently. We're still tunneling down towards the ground, I guess, but once we get there, we're actually detecting correctly if it's a depth, instead of using that there's no leaf nodes or something like that. So theoretically this one will work, and if this one doesn't, I'm going to be very annoyed. Oh, for this to work, you have to actually use it. That's important. So we're here, leaf.data. We want to do isLeaf. No, wait, no. Why? We don't need that. Sorry. That we can just take that off. We're only getting the leaf nodes. We don't need to check if the leaf nodes are leaf nodes, because we know the leaf nodes are leaf nodes because they're in the leaf node tree. Leaf node list. Anyway, that was a ramble, but that's fine. This should work now. If this doesn't work, I am doing something horrible. I am doing something horrible. Oh no. This doesn't really make any sense. Are we building our tree correctly? I'm starting to think we may not be building our tree correctly. Did I screw something up when I was opening this? Because that doesn't make any sense. Because it suggests that we have not inserted anything. Which doesn't make a bit of sense, honestly. Found the issue. So we added all of these depth values, but we didn't actually use them. Oops. So don't do that. That's wrong. Okay, it's still not there. Now literally everything is gone. Null references. Good. Something broke. That is better than nothing. What was it? Let's go to the first error. This one happened first. It's the same error. Subnodes.nodes. So previously it wasn't breaking because our isLeaf was correctly detecting that it had no leaf nodes and was therefore preventing it from doing anything. Now we need to actually do that check ourselves. Is not null. And I think if it's initialized, it will have values in it. I think we can just say that flat out and say if it is created, then there will be something there. So now we should be able to run this. That's better. And now everything broke again. Null reference at 122. So this video is pretty much turning into a bug hunt, but I kind of knew that going in. We have the same issue again. So if our nodes is not null, then we can do all of that stuff. And I think that should be it. Cool. Node, get leaf nodes, yeah. Cool. So let's try that and see what happens. Well, let's not pause it. Let's actually start it. There we go. This should work. Hey, it worked. Cool. I didn't break everything. Issue is that, well, no, because we're just detecting leaf nodes right now. We're not detecting data. So one of the important keynotes is not all 4 of these things in that leaf grouping may be needed here. Some of them may not have had data inserted into them. They're just leaf nodes. That doesn't necessarily mean that we put data there. It just means that we eventually subdivided down to the point where we got as precise as we wanted to in that point. So we should be able to fix this now, because we should be able to actually use this isLeaf to detect things. And I already know this doesn't work. Why did that work? Oh, that was isLeaf, that wasn't the data. I'm going all over the place today. That's great. So if we run this again, everything should not work. Yeah, good-ish. So if I attach to Unity now with Visual Studio's debugger, we should be able to hit this generate again. And that should have hit this, but it doesn't appear to have. There we go. Okay, just took a bit. So why is the leaf false? That's not really what I was expecting. Well, I know it wasn't what I was expecting. So if we just keep digging down into these leaf nodes, eventually we'll get to something and it will be false. But that one's true. So wherever we are, I don't really know, I just kind of picked a few at random, but wherever this is, there is a data node in here that is saying it's true. So the question is, why? Oh, it has a depth of 1? Did we screw up that? That may be our issue then, is that we're incorrectly setting the value because our subdivide is incorrectly returning like 1 node up or something like that. If that's the case, then it's going to be broken. But that doesn't make any sense because I'm pretty sure this code works. We drill down to a depth of that and then return back the result. Oh, but this is not correct, because if our depth is greater than or equal to 0, then we want to subdivide. And then all the way at the top up here, if our depth is equal to 0, then we want to return it. So the problem we were having is that we were incorrectly determining the depth. And so we would drill all the way down. And then instead of returning this when we got to the bottom, we would return 1 up from that, which would set the value at something that wasn't a leaf node, which means it wouldn't be drawn. So this should work, I think. We'll find out shortly. But now we should drill all the way down until it equals 0, and then return ourselves if we get that far. The only issue now is we are here. Well, actually, if the depth is greater than 0, so we can actually remove this depth check entirely because we put our exit status. So recursive functions always need something that gets them out of themselves. In this case, that's right here. Previously, we had it all the way at the bottom. But since this is going to get us out, we can actually recurse here without without too much concern, and it should be fine. So that should work out for us. So we should drill down, hit this, return it, and then that will bubble all the way up thanks to this. So with that as the case, we should be able to restart this. Everything should have compiled. We didn't go down far enough. So our depth is not going down far enough, which is a problem. How do you solve this? We could return -1, I guess. So the issue is this depth is equal to that, which means we're never going to create the leaf nodes. So how do we fix it? Relatively easily, actually. If we do this is equal to the, no, that won't work. Actually, yes it will. So if we set the nodes to have the depth -1 as their current depth, then whatever's at 1 will actually have -1 as the depth, and this will just continue to iterate down. This is just decrementing it, and this is actually setting the value. A little confusing, but that's how it's working. And then we had a -1 up here. We can take that away now because we already inserted that into our code. And so this should actually get us drilling down as deep as we needed to go. There we go. Everything looks normal. And then we should be able to do that. And we get our voxel data. And so this is actually filling out our graph correctly. I'm going to actually increase the depth we go. Let's go to 6. So this should be far more precise. Yeah. And so I can do something like that. And now here is sort of our map created from that image. And you can see we're saving quite a bit of space from not filling out everything. This is a sparse voxel octree or just a sparse quadtree is going to be more effective the more empty space you have. So like we've got this whole empty upper bit, and so because of that, there's a lot of space that we're not using to do this. If you fill the entire thing out, you're wasting a bunch of space by using a quad tree, but because of this, we're actually gaining quite a bit. So I think this is a good spot to leave it because it works now. It didn't work previously, so progress, I guess. So next steps, we need to actually turn these quads into mesh generation. And I think the first step is actually to generate a unique mesh for each leaf node, which is, we're pretty much going to be regenerating those quads, but we're going to be using a mesh generator to create that, which is a bad idea. But the reason we're doing that is because when we get to the marching squares, each of these is going to need a separate mesh depending on its adjacent nodes. And so I think that's a good place to start work on that. So we'll see how that goes in the next video. But that's it for this. So if there's anything you guys want to see, let me know in the comments. If there's anything you think I should change or improve or anything like that, let me know about that as well. I'd love to hear it. But that's it for now. So until next time, see you, Internet.